you download this morning, it should be okay. If you download earlier, maybe last week, you may need to re-download because we update the version to version 3, Lab 5 version 3. If you notice, right, I know sometimes you all cannot control your emotions, right? Waking up 8 o'clock to attend class. So I don't want anything to be against you all. If you take a look, right, for Lab 1, even though I don't record the class, which is because of the privacy of my student, I also record some steps you can do, you can complete, right, the installation and can complete the assessment, right? The second part. The first part, I think Dr. Robito already make the video, right? And also Lab 2, if you check your email, Lab 2 also I send you some recording. The recording normally, I don't have student inside, so I don't have any problem of privacy of my student. So the third one is because it's rather simple. I don't have any student writing email to say they don't understand. So I assume the third assessment was pleasantly passed, right? The fourth one, there's no assessment, right? And is the step is all written in the manual. So there is no required, no need, right, to have additional video. And the fifth is also the same, right? If you take a look, the fifth lab, we don't have any additional things that are not inside the manual, not inside the lab manual. If you take a look, today what we are going to do is forward to the concept of security, right? Now, just to refresh back, right? The first lab, right? We did with the encryption, user to user, right? And the second lab, we did a Linux system to ensure the security of your own system and how to secure your files and provide rights or permission to the files, right? On top, we teach you how to download files that are not within your network securely using SSH. The third one, we talk about malwares, right? And to secure your devices and we call it devices. Why? Because it's your end devices. It's either your computer or your laptop or your personal information, right? Secure your devices or information. This one we completed using Sandboxy, right? Keylogger, how to dodge a keylogger, right? How to do VNC, what is the role of firewall, right? So, and then the fourth one, we did the network, right? We provide security over your personal network. You see, last week, what we did is how to secure your own network against external, how to enable your own network to enable some services, right? And today's lab, we are going to provide also network security in terms of the now if you see this, the 1, 2, 3 is about device, file system, user to user. 4th and 5th is about network security, right? So today we want to ensure you have network to network security, right? Network to network security. Now, why I say network to network security? If you open up your Lab 5, right? Your Lab 5 kit, your Lab 5 version 3, right? So you are going to do site-to-site IPsec and also ACM, right? Now, if you take a look at this, this is the example of a network whereby your router 1 is your network, router 3 is your the network of your client, for example, right? The network of client wants to have a secure communication with you, right? For example, it can be your network and your network of the client. Now, what does it mean, right? Now, in network perspective, we have the R1 perhaps is your right. If you take a look at here, right, you have your now you have your network. Assuming this network here is your is yours. It is your network, right? It's your network. Is your network. This one is your network. This one is your client network, right? So this one is your client network. Now this is the public network. This is the public network. This is like a cloud. This is like a public network. This is a public network. So how are you going to secure your the fifth one gone already. Hey, wait, right. Right, assuming this is your network, this is your client network, right? So this is the public network. Right, so this is the public network. So you have your network, your client network, and your public network. Now, how to ensure your network connected to your client network is through a secure channel? Because public network, anything can happen. As you can see now, you know, oh, there's only one router. Maybe in the public network, there are thousands of routers. You do not know, right? Within this service provider, of course, within this service provider. Now, I'm not going to do in detail the service provider concept because you're not networking students, right? So roughly, it's a public network, and this is your network and your client network. How are you going to ensure, right, network to network security? Now, if you take a look at your lab, the title, site-to-site IPsec, VPN, virtual private network. The concept of virtual private network has been there. But in the past, the virtual private network is very expensive. We used to call the private network as a lease line, for example, right? In the past, right? We have the lease line, right? Most MNC, I would say multinational corporation, does have a lease line. For example, last time I worked with Panasonic, right? When after I graduated with my degree. So I worked there for 7-8 years. And the lease line that I have is directly connected to the Japan, to the Honbu or to the center, because I deal with the design and I deal with the production, right? And these lease lines are very expensive and very dedicated. But the lease line ensure that I have a secure channel so that I can download data from Japan down to Malaysia, right? Securely in the past. But lately, there is a technology called VPN, Virtual Private Network. And Virtual Private Network is divided into 3 types. We have a site-to-site virtual private network, host-to-site, and host-to-host. Now, there are 3 types of virtual private network that deploy the IPsec, right? As I mentioned, we have 3 types. The first type is site-to-site, as what we have here. This is your network and this is your client network, site-to-site. And then we have the IPsec or VPN to host-to-site. Now, this is when you have the work from home, right? When you are host-to-site, meaning I am working at home and the site is the company. So what does this usually mean is that is usually using so-called a secure virtual private network directly to your company. So for example, here R1 is yours, right? And you are working at your home, right? So perhaps you have a device here, right? Okay, what happened? Oh, because I'm drawing. Okay, and then the third one is, and then the third one is what I mentioned is host to host. So we have 3 types of IPsec VPN: site to site, host to site, and host to host. For example, I was explaining host to site. For example, this is a private network and you are connecting it to your home, right? So what you actually have is you have a PC, like a laptop at your house. You have a PC at your house. Right? You have a PC at your house, right? So this PC log into your R1 using a secure channel. How are you going to do the host to site? Host to site VPN. And this is host to host. That means if you are transferring host to host, assuming you have many routers, right? Many routers. And then this one is connected to another PC. Right? So you have a host to host. This is host to host. How do you configure VPN from host to host? Same. The concept is same. We are going to teach you the concept, but you can apply those concepts to host to site or host to host. Right? Now, when we want to deploy the VPN, whether it's site to site, host to site, or host to host, we must do configuration. And you realize that if you want to work from home, you need to And if you are using VPN, right, not using public network like what I'm doing, right? I'm using my mobile network, right? And I just log on to Utah. I didn't do a VPN because I didn't transfer important information, right? So it depends, right? For example, if you do a VPN host to site, you are accessing some system in the company, right? That's why you do a host to site. In this instance, I'm not accessing anything in Utah, so I don't need to do a host to site, right? So if you take a look, site to site, host to site is this, right? Host to site and host to host, right? You have three ways. This is site to site. Okay, I should use another color, right? This is host to site, site to site, and host to host. This is the, oh sorry, this is C, right? So this is C, this is B, this is A, right? No doubt. Now, if you take a look at lease line and VPN, now there is a many story in it, right? The lease line is actually the service offered by the telco. That means offered by a telecommunication company like Maxis or TM, right? So TM mostly benefit from this, right? But the VPN technology, right, is developed by the Internet Engineering Task Force, right? So this is a standard, which means the telco just provide the data and the network administrator can admin this connection. Now in the past, why I say telco? In the past, if you want to have a lease line, you should apply to the telco, and then the telco will say, oh, I have bandwidth about 126 kbps. You have to pay 30,000 per month. I have 256 kbps. You have to pay 60,000 per month. The telco will give you a list of services you can order. Then finally you say, okay, I have the first plan, which is 30K per month. And all these are managed by the telco. Now then comes the IETF, whereby they take the business of the telco and do it on their own. The engineering task force, Internet Engineering Task Force, did what the telco used to do. Why? Because the VPN can be configured by you and me. We don't need the telco to quote or the telco to tell us how much is it, right? So the VPN is controlled by the company itself. The company no need to, hey, telco, I want to skip this plan. No. You have to pay the 30K for 1 year minimum, right? But IETF for VPN, today I want it, I can set it up. Tomorrow I don't want it, I can break it down. I don't need to have a so-called contract with the telco within the internet. Within the internet. So this is the beauty of VPN, right? On top of the lease line. Now then, if you look at so this is the basic concept of VPN and also what we are going to do today. If you take a look, today we have only 2 tasks, right? It's very simple task. We are going to do some revision back in the Lab 5A in configuring IP for ACL to mitigate attacks, like the one we did last week, right? Now why we do again the ACL is just because we want to refresh you the concept of ACL again. Why? Because in order to do VPN, we need the ACL. So Now, the first step is to configure the IP ACL so that you can do the first round of secure network, which is to mitigate attacks for those IP that cannot log into the network. For example, you want to prohibit some PC around, right? You only want to permit some PC to log in. Then you already, with the ACL, you already can mitigate some attacks, which means you already can do the first round of filtering, right? Now, so if you take a look at the basic of connectivity, right? This one, please open up your topology for your ACL, right? If you take a look at the lab, you have the ACL topology here, right? So you can open the Cisco Packet Tracer. So this is the ACL topology, right? And then you can see that you have another one, which is the VPN topology, right? You see the difference in the both topology. The VPN has 3, right? The ACL only have 2. We go back to revising the ACL topology. Now, step 1 is to from PCC command prompt ping PCA, right? Open the ACL network topology, and verify network connectivity, right? You have your this is this is your ACL topology. So verify your connectivity. You can verify you can click on this button, right? Send message from server to PC, right? Send message server to PC. Too many. So for example, you send a server to PC, right? It's successful. So the ping will be successful, right? So from PC command ping PCA, right? PCC. Where is PCC? PCA server, right? So if you can use this, this is a sending message. It's like a ping process. You can click on this and ping PCC to PCA. It's successful here, right? So this is successful. This is without the ACL. So if you open the browser of PCA server to display the web page, right? You can have a browser, right? Services here, right? And then you have your HTTP services, right? Open PCC, open a browser to the PCA to display the web page. Now, if you are in PCA, you notice that the HTTP service is switched on and the HTTPS also is switched on. Right, this is important. Just double check whether this is switched on or not. Right, and then you can go to PCC, and in the desktop, you go to the browser and you input, right? You input the IP address of this PCA, which is 192.168.1.3, right? So here 192.168. The dot 1.3, right? So you can see you are accessing the web page of here, right? Just now I already showed you the web page is actually active. The web page is actually active. You see services here, HTTP is switched on, right? So from PCC, which you open the browser and you can display the web page, and then you can close the browser of PCC, right? You can display the web page. But right, you perhaps wants to do a ACL, right? From PCA server command prompt, you can, and then to check, right? From PCA server command prompt, you ping PCC. Of course, no problem. Everything can work, right? In the short, all these step 1, step 3, and step 4 is to ensure that all this is working, right? All this is working, right? Right. So yeah, so this one initially we have done already. I don't know why they do so many times. Anyway, then the task 2 is mitigating anti-spoofing with ACL. Now we know that ACL comes with standard ACL and extended ACL, right? We have a standard ACL and extended ACL. So let's go for standard ACL, right? Again, right, ACL we have standard ACL or extended ACL. Or extended ACL. So standard ACL have a number, right, between 1 to 99, right? And this one 100 and above, right? More than 100. So if you take a look at this, right, lab 5, you have ACL 100, which means it is trying to do an extended ACL. Now, if you follow my Datacom class, right, extended ACL is mostly for services, right, or more in-depth permission or obstruction, I would say. Permission, either you permit or you obstruct or you deny, right? So in this case, you want to deny, right, all specified traffic from the outside network, right? You want to deny, right? So what did you do with protecting your own network? If you look at this is protecting your own network. You want to mitigate any network in the public network that cannot access your network, right? You want to mitigate that. So in this instant, if you take a look on R3, right? On R3, block all packets containing the IP source from the following pool of addresses, right? Any RFC 18 private addresses and any IP multicast addresses. So what you did is, for R3 here, you want to deny, right? Block all packets containing the IP addresses from 127. This is deny 127. Are any RFC 1918 private addresses, which is 172.192.2, right? And this 10.0.0. And any IP multicast addresses, which is the 224, right? So you have to block the 127, which is your, which is what you specify here. And multicast IP address is the 224, is the multicast IP. And the rest is the RFC 1918 private addresses, which is the 10, 172, and 192. So this is your specification to your R3, right? So you should also block traffic source from your own internal address space if it's not an RFC, right? So in order to mitigate attack, you want all those private addresses, all those IP multicast addresses, and also your own addresses here. 127 is your loopback addresses. That means your own, right? Unspecified from your internal address space, right? So this is your internal address space, 127. If you completed Datacom, you know your 127. I think Avocado should explain, have already explained to you all these addresses, right? So 224 is your multicast, 127 is your private addresses, your personal, internal, right? This is your private addresses within the network, 192. Remember why we always use 192.168.1.1? Because this is private addresses that is not within the internet. That means this is not a public address. All these cannot be public address. This only can be private address. So there we go down, right? So apply the ACL interface to serial 010. If you take a look at your network here, right, 010, apply it here. And apply it in. Right. I don't like the, I like this image better. So yeah, maybe I will print screen this image. So what you do is, for this network, right? For this network, you will do the following configuration, right? You will do the following configuration. Right? So you are going to put your ACL here. You're going to put your ACL here. And then the ACL is going to be in. Why? Because this is a public network. As I mentioned, this is a public network. So you want to mitigate attack. You don't want public to attack you. So this should be in this interface, right? You put the ACL here and it should be in. Now, as I mentioned in last week class, you have two things you need to take into consideration, right? The first thing is write your ACL. And the second thing is place your ACL in the interface. Which you do. The first one is, this is the first one, and this is the second one, right? So this is the first one, this is the second one. So let's complete this, right? For me, first I need to write the ACL, and as again, right, you can only write the ACL in the config, and you can place the ACL in the interface, so config if. So for those without any knowledge, right, I'm sure all of you already like Avocado very much, right? Datacom, he already teach very well. So I don't think you all have any problem, but still I will do some revision in case some of you already forget. So you have a different mode, right? Remember, you have different mode, right? And you have a so-called user mode, privilege mode, and then a configuration mode, and then interface, right? So you have all these mode, and all this mode, in order to progress, right, from one to another, you have a command, right? So from user mode to to privilege mode, you have to type enable, right? Enable. From privilege mode to configuration mode, you type config T, right? And from configuration mode to interface mode, right? You type interface, right? And if you want to exceed the mode, go back to the lower priority, lower privilege, then you need to type exit, right? Remember, you need to type exit. If you want to go from configuration mode to privilege mode, you type exit. Privilege mode to user mode, you also can type exit. So, yeah. So with this, let's start configuring, right? And how I know what mode am I, right? For user mode, right? My R would be in this format. For privilege mode, my R will be in this format. Configuration mode, my R will be in my R2, R1, then I have config, and I have this, right? For interface, R1, config, I have this. So each type of mode, when you see this sign, you already know what mode you are. Okay. So if I see this sign, I am in user mode. I can type enable, and then I type config T. I'm in config T. I'm in config, right? So then I will enter my access list. If you see my access list, I want to deny all the IP that belongs to any group, right? So this is extended. So I want to deny, for example, access list. I want to make access list 100 deny IP 10.0.0.0 255.255.255.255, right? Now this is not your subnet mask, or this is your wildcard mask. That means all the IP. And then you have any, okay? And then you can deny 172.16.0.0 015 dot 255 015.255.255. Yeah, my keyboard is a little bit serious, So then you deny same 00, right? So you deny same 00. This is 192.168, right? And you deny 127. Right? Then you deny 224. 224. This is your multicasting, right? 224, and here is 15 because 224, right? 255. So there you go, and then after you deny all the IP above, right? You want to permit the rest, right? right? So this is your mitigating attack ACL, right? And then you want to place the ACL in the interface. So you have to go to the interface, for example, interface S010, right? So then you will go to config if and you put IP access group 100 and it's going inside to the network. So this is the way that you should mitigate, right? So from PC2C command prompt ping PCA, right? The ICMP echo replies are blocked because they are from this network, right? Now, just now you can ping and it's successful. Now, if you ping, right? So you exit, right? Now you are in user mode, for example, right? Now, if you take a look back into the network here, because you want to prohibit, just now in here, you want to prohibit the 192.168, any IP within here. So now the server IP, if you take a look, the server IP is 192.168. The server IP. Where is it? Oh, here. So if you take a look, your server IP is here, right? Your server IP is here. This is 192.168.1.3, right? This IP. So if you wrote your ACL here, right, to deny this, so obviously when you ping, right, when you ping PCC to PCA, it will not happen. Why? Because you place the ACL here already to prohibit. So now if you try the service, right, if you try the service, this is the later one. If you try to ping PCA to PCC, you will see it is not successful, right? PCA to PCC, you say it's failed because the ACL is in place, right? So this is how you mitigate personal network, right? So if you remove the ACL again, it will be able to ping, right? So we have completed the task 2, which is mitigating anti-spoofing with ACL, right? So now your network, this network is secure. This PC cannot, for example, now if you go back, right? If you stop and go browser 192.168.1.3, right? You can see that the browser no more can access the server web page, even though the server has the HTTP or the web server switch on, right? So in order to prevent, right, you can mitigate, you can put in place the ACL to prevent other private network to access this network by doing the ACL, right? At the moment, right? So if, for example, this kind of network, right? There are many. There are many. Let's say there is one here, right? There's one connection here which has a private, right? Which has a private. Let's say there is something like this. This is a private IP. So then the thing is, you want to prohibit this kind of private IP other person network to hack into your system. This is the mitigation process. Of course, now you do not worry, right? Your PCC will be able to be hacked by other network, right? So same, I delete back this, right? So, and another case is I go back to enable, go back to config T, right? And then I can go back to interface S010, and then I can put no IP group, right? I can no IP access group 100 in, right? Right. So if I nullify, this is to nullify just now the ACL I placed here. If I nullify the ACL I placed here, you will see that I can now use PCC and access the web page again. And if I ping from this PC to this PC, I can be successful. The PC can ping successfully. So placing an ACL here is very important if you predict some attacks will be from that list of IP. Now, the thing is, the list of IP is not necessarily this list. Sometimes you can check your record of accessing, right, for the PCC. Then you say, oh, for example, your employee always access this IP, and this IP is nothing to do with work. So you may want to draw an access list to deny your employee to access this IP because you think your employee is spending not enough time in his work and accessing some XYZ website. So you can deny the IP so that your employee will not be accessing this website. Now, this is if you are the network manager, right? You cannot do it if you are only the staff, right? For example, you have a colleague who every day play game and you have to do all his work. Then you say, oh, I want to mitigate the IP for the gaming, so that he can help me at least to complete the work. If not, the boss gives us work, but I have to do all, something like this, right? So you need to deny it so that you can mitigate, block specific traffic from the outside network. Okay, same case. So that would be all for your mitigating anti-spoofing with ACL. So task 1 and task 2 we have completed. Any questions? Any questions? An Ming Wei, any questions? Hu Heng Chun, any questions? Have you completed? Lok Jun Leong, have you completed task 1 and task 2? Have you tried out? Okay, good. So let's move on. Shall we move on to task 3, right? Now, task 3 is to permit traffic from inside only. Just now, we want to mitigate at some outside traffic, right? Now, we want to permit traffic from inside only. That means if this is your network, if you take a look, if this is your network, this network is, for example, 192.168.3.0, right? Let's say this is your network, and you want to permit traffic from inside only. That means deny all outbound packets with source address outside the range of internal address, which means that in other words, you don't want the employee to access anything outside. That is a very big one. Now, when is the situation you have this kind of situation? For example, last time I was in design department. For a design PC, right, we cannot access the internet because we are afraid the design will be hacked and our work will be in jeopardy. So for those PC, they are very secure. That needs to be secure, right? Because we are doing sole design work. For example, so you want to only permit traffic from inside the network only. That means, for example, let's say I have student, right? Ku Heng Chun, Lim Kang Ji, and Huang Zikai, 3 person. 3 person. Ku Heng Chun, then Huang, and Lim, for example. So this 3 person is in charge to design something in a personal network, right? So, okay, let me cool. This is maybe cool. Then I have one more PC, right? I have one more PC. Right? I have one more PC. Okay. Wait, I have one more PC here. Okay. I have one more PC here, right? And then I have one more PC here, PCB, right? And then I have one more PC, PCA, right? This is PCA, right? And then this is Ku, this is Huam, this is Lim. I want to enable these 3 PC to talk among each other only, to talk among each other and not go to outside, right? So you can communicate among your PC, but you cannot go outside, these 3 PC. How are you going to do that? Now, if you hard code it, that means that if you throw the connection away to the R3, it is also the same, right? But you do it softly. For example, if you take the connector out from the router, you also prohibit, right? But if you do it soft way, means you do the ACL way. In here, you place the ACL again, right? You place the ACL again. Software softly not take the connector out is the same case. It's the fastest and same case. So what we want is to permit traffic from inside only. So now the ACL is permit IP of this 192.168.3.0, right? For example, in these circumstances here, this is .1. This is .2, this is .3, right? So you only want 192.168.3.1.2.3 to talk among each other. So what you did is you do a ACL and then you place the ACL in your FA00, which is your this side. If you take a look, FA00 is your this side. That's why I said place your ACL here. And this one is in, right? It's in because you see, if it's in, is the outgoing traffic. Outgoing traffic. You place it in. So this way, you also can permit traffic from inside only. And actually, as what Dr. Lau mentioned, you can just take the connector, this one, from the R3, take it away. It's the same as placing the ACL in interface FA00. But that is a hardware. This is a software. This is the coding way. That one is the hardware. Okay. So see how to do the hardware. How to permit only internal configuration. So we go back to here. We said, right? We want to configure the here. Right? So the access list, now the access list 110, right? Permit IP only from the inside. 3.0, 0.0.255 any, right? So, and then you place the ACL in the interface. So interface FA00 and IP access group 110 in, right? So that would prevent all this IP to go out. You only permit communication among Ku, Huam, and Lim. Okay, so this is the example for task 3. Okay, understand? You can do more PC but at the moment the ACL topology only have one. Lem sweater, okay. So I hope you all can follow, right? I'm going very slow already. Usually this class 1 hour can finish, but I'm going very slow because yeah, I want to do step by step. Now then, task 4 is about permitting necessary traffic, right, through a firewall. For me, after I do this, I of course nullify first. I need to nullify first. If not, I cannot permit. Okay, now didn't ask us to nullify, right? So task 4 is permitting necessary traffic through a firewall. Remember last week we already know what is the role of firewall, right? When we switch on the firewall, the VNC cannot run, right? The VNC cannot run. And also last week when we switch on the firewall, the syslog server cannot log any data, right? And also when we switch on the firewall, the some of the IP is not able to pass through, right? So permit any outside host to access the DNS, SMTP, FTP services on PCA and deny any outside host access to HTTPS service on PCA and permit PCC to access R1 through the SSH. So many. So you have the first one, to permit any outside host to access DNS and SMTP, FTP. So you see this is permit any outside host to access the DNS, the SMTP, and the FTP. Deny any host access HTTPS service. Deny HTTPS service. And permit PC to access R1 through SSH. Permit this PC, so it's a host because only this PC to access R1. R1 is the 1.1, which is the public, right? Equivalent to SSH. SSH is 22. So this is the first one, this is the second one, and this is the third one. Okay, so let me copy this. So if you take a look at this, right, for these three statements here, it refers to the first one. And this statement here, deny any outside to HTTPS to service A, is this one. Right? And the third one, permit PCC to access R1 through the SSH, is the fourth one. Right? Or the third one. So each of these, we teach you how to configure. Now you see DNS is a UDP. Right? If last time you attend avocado class, you know DNS is a UDP, SMTP is a TCP, FTP is a TCP, and HTTPS is a TCP, SSH is a TCP. Now, when is the situation is a TCP is because TCP is a reliable service. Remember the word reliable. SMTP is an email. Email arrive or no arrive is reliable. If it doesn't arrive, Google will send you back your message didn't arrive. It will not just disappear without acknowledging anything. If the email arrive, it will tell you in the outbox called send, right? Is a reliable service. FTP is same. If you cannot download, you cannot access, FTP will tell you you are not able to download. It won't just be there and then don't tell you anything because it's a reliable service. Same. SSH and HTTPS is all reliable service. That's why it's using the TCP. The TCP has acknowledgement. Where else the UDP? The UDP is a non-reliable. Non-reliable means if it arrives or it doesn't arrive, I don't care. I already sent it out, right? So if you usually, for me, if I want to joke, right, I would say, if I have a friend who is reliable, I can say my friend is a TCP friend. If my friend is unreliable, that means every day, every time he make appointment with me, he sure lat Taiwan, he sure cannot come on. So he is a UDP. Hey, he's UDP. You be careful, make appointment with him. Okay. Or he's TCP. You make appointment, you better go. If you don't go, he will scold you. Okay. So can be adapt to the characteristic, right? I always tell my network student, you can use this TCP and UDP so that it's a secret among yourself, you know, to describe a person, right? So now, when is the situation is UDP? For example, WhatsApp for voice, right? Or usually when you call your mother or you call your friends, right? If the packet is missing, it's not going to tell you the packet is missing. For example, sometimes the video, suddenly the video is not there, video is there. The video is not going to tell you whether the video packet didn't arrive. You please stop again. No, you please send again. No, because it is real time, it's already passed. Real-time packets, normally we do UDP. If real-time packets we do TCP, there will be a lot of delay. So real-time packets is always called UDP. So for example, if your network is not good, right? Now Dr. Lau is speaking, it won't send you the message that is lost. If you cannot hear properly what Dr. Lau is saying, it will not tell you what message is lost. That is UDP, not reliable service. TCP is always reliable service. For example, your email, it will tell you your email arrived or not, email not arrived. Your FTP, whatever you want to transfer, does it arrive, not arrive? It will send you acknowledgement. All this. So I hope you know the difference between TCP and UDP. So this one, so we want to permit necessary traffic through a firewall, right? So the first is we configure again the extended ACL, right? And then if you take a look, we place the ACL in the R1, right? Now we are doing the R1, right? Because we are configuring this side. Just now we are configuring this side. Now we are configuring this side. So what it means that now PC0, right? If we go to packet tracer, right? Now if we go to 192.168.1.3, right? You are able to, right? You are able to access, right? Right? You are able to access, right? Because it's HTTP, right? So, okay. And if you are permitting UDP, TCP for domain, SMTP, FTP, configure it in this side, right? Configure in this side. Now, just now, if you notice, you allow all the PC to communicate among each other, right? So now you allow your R1, the server here, because the server is placed in R1. So you allow R1 to permit any traffic of domain, SMTP, and FTP. So R1, I go to configure the domain, right? Enable, and then config P, right? And then access place 120, permit UDP any host, the IP address, host 192.168.1.3, 1.3 equivalent to domain, yeah, EQ, right? And then permit, now instead of UDP, it is TCP equivalent to SMTP and equivalent to FTP. So now I have complete 3, and then now I want to deny, right? You want to deny any TCP from host 123 equivalent to 443, which is your HTTPS, right? And then the fifth one is you want to permit TCP host 3.3 to host 10.1.1.1 equivalent to okay, yeah, permit TCP host 192.168.3.3 host 10.1.1.1 equivalent to 22. This is your SSH. Okay, so then you want to apply it in your incoming, right? If you take a look at your incoming, right, then you apply this one here, right, in your FA S, or in your S here, incoming, right? So you want to apply your ACL in this, right? I should choose different color, right? Maybe I choose green color, right? So now you want to apply your ACL, third ACL here. Third ACL here. Okay, so just now I explained this one. Okay, wait. Because there is no deny, there's no deny. There's no deny. The ACL here is only indicating, right, these 1, 2, and 3 is permit to talk among each other in this ACL. So which means that this COO can send packet to here. This limb can send packet to anyone. Can send packet to anyone. Can send packet to anyone. This is a permit, right? Just now it's not a deny, it's a permit. Is a permit. You see, it's a permit, right? You permit all the IP, right, to traffic inside, right? To freely send traffic inside. Okay. So if you take a look at this one, you are again permitting traffic from outside, but you are denying two things. You are denying the TCP, any host from any to host, right? So you're denying the HTTPS. You are denying outside people to access the HTTPS service, and you are denying the outside host to access the HTTPS service, and you are denying, only one deny, and you are permitting a TCP host. Wait, I think I configured wrongly. Okay, I configured correctly. You are permitting a TCP host to access from 3.3 to host 1.1.1. You are permitting PC3 or PCC to access R1 through the SSH. So this is the third one. So, okay, so you are denying only one thing. You are denying the access of HTTPS. You're only denying that. Other things you permit. Okay. So this is the third one, right? So let's configure the third one, right? In the interface S010, okay? Interface S010, my IP access group 120 in, right? So it is in. because as I explained just now, it is into the server, except HTTPS or the other service you provide, right? So if you take a look at the PC, if you take a look at PC, right, you still will be able to access the 192.168.1.3. Okay. 192.168. I placed the ACL here. Wait, I placed the 120 in as permit permit TCP. Oh no. Okay, I didn't permit any sorry, I didn't permit any HTTPS. So what you cannot do now is you cannot access the web server already. Now you cannot access the web server because you deny the HTTPS. You deny the HTTPS. So which means that you cannot access the server in the HTTPS, but you can access but you can go to the terminal, right? Or you can go to the FTP and you can ping 192.168.1.3, right? Or you can FTP 192.168.1.3, right? You can ping what is the configuration? Wait, FTP Cisco. So Cisco, right? Now you are at the FTP. Now you are at the FTP, right? You can FTP. The PCC can FTP, no problem. Can even email and can do DNS, right? No problem. But just that it cannot, right? Just that it cannot HTTP, right? It cannot do website access. Okay, so these are all the first few revision, right, for your ACL. You can permit necessary traffic through a firewall. Right? Okay, so now we are going to the VPN IPsec already. Lab 5B. So if Lab 5B, we are moving to Lab 5B. Lab 5, task 4, is it okay? Very funny, today's lab. Task 4, is it okay? Wong Hui Shi. Task 4 is just prohibiting some service, enabling some service using ACL also. Is a something like a revision for ACL. And this ACL is quite important because it will support network to network access. As I mentioned just now in the beginning of the class, today what we are going to do is network to network security. What we did just now is prohibit others' network to do something, prohibit your network to access something, for example. So network to network security, today what we are doing. And then the last part is we are doing the VPN. Using, today what we did is using ACL and VPN. Okay. We have finished the first part, using ACL to secure network to network security. Okay, now we are going to the second part using the VPN. Lim Kang Ji, okay? Ku Heng Chun. Okay. Task 1 to task 4 finish. Lok Jun Leong. Again, just to revise, today lab, there's no assessment, right? Just knowledge. And next week lab, we have assessment, 2.5 marks. So let's move on. Hey, Lim Kang Ji, okay or not? Task 1 to task 4. So, okay. Okay, let's move on, right? So, now we are going to do the VPN. Now, setting up the VPN actually is quite simple. As I mentioned before, previously, right? In the past, right, when we are doing the lease line, is offered by telco, and telco will configure. Telco has the total control over their services provide, right, using the telephone line. That's the lease line. But VPN is offered using the data line, right? The lease line is using telephone line, right? Is used usually used dial up, right? So then we move to VPN. Now, if you take a look at the lab for VPN, you have two ways to configure it. Now, this one we have already complete, right? If you want to save it. For me, I'm okay, right? I don't need to save it because tomorrow I have to use it again, right? So for lab 5, right, task 5, right? So you have to configure and verify a site-to-site IPsec VPN. So we are going to teach you the most general one, site-to-site. Remember, there is 3 types. The configuration is also same, site-to-site, host-to-site, and host-to-host. 3 types. You see here, site-to-site, host-to-site, and host-to-host. But we are going to teach you the first one. You can apply second one and third one also, no problem. Now the key point is this: you have two network which you think you want to form a secure channel, because this is a public network. Again, I use this is better, right? Because I have all the interface. So I move this one to my desktop. VPN, right? Let's start here. Now you see, we are assuming, right? This is your network. This is your client network, and this is the public. Again, this is the same case as what we mentioned just now, right? This is the public, and this is yours. This is your client. Now, the public, as you notice here, maybe now the public only one router, but in fact, public router, maybe there is 100 of router around the public, right? So, and between yours and your client, there are hundreds of router in between. It's okay, because in the configuration, the most important part is these three parts. Now, you take a look. The first part here, this is the first one. The second part here, this is the second one. And the third part is in the configuration of the router to generate the key to decrypt. Why? Because once the packet, now listen, once the packet, right, once the packet go out from here, you are going to use the encryption technique, which is in 3, right, to encrypt the packet from here, right? And it's going to anywhere, but to when it deliver here that time, because he knows the two setup, the second setup, right? The second setup here, and he's going to decrypt using the key that is generated in the third step, so that when it flow here, the same message, which is the message form, this is the encrypted form, will go back to the message form. Okay? So there is 3 setup, as I said. The setup that is outgoing router interface, incoming router interface, and also the key. The key. So if you take a look in the lab, you have why we call IPsec VPN, because it's a security segment. Okay. So now you have the S101 and 101 at the R1 and R2, right? And then 110, 110 at R3 and R2, right? Okay. So these 2 IP is important. Remember, I said this IP and this IP. This IP and this IP. So which means that which IP is important? This IP here. This IP is .2. Okay. This IP is .2. This IP here, number 2, is also .2. Okay, these 2 IP is important. Remember the number 2 and number 1. That's why it's marked here. This IP, the 22 and the 12. The R1 IP is important and the R3 IP is important because it's the peer. Okay. So if you take a look, and then the third thing I say important is the encryption, the ISA-KMP policy parameter, which is the encryption technique in R1 and in R3. What key they want to use, what kind of hash algorithm they want to use, what kind of password they want to use. These will allow them to generate the key, right? Will generate the key. You see, this is the step of 3. Step of 3 to generate the key. The step of 1 is to ensure, right? Now, why I say step 1 and step 2 is important in the brown color? Why? Because the only thing, now, once we are outgoing, means this is a public IP. Once we are outgoing, we know that the R3, which is here, will know that this IP is very important to this R3. And in terms of R1, this IP is very important to R1. So that is why this is the first foremost and this is the second foremost, because from the perspective of R3, if I want to transmit securely, I can only identify the destination, which is this destination. In terms of R1, the only thing I can identify is this destination, right? So, and if we identify both destination, the important thing is the encryption and decryption, which is done in step 3, right? So R1, this IP is the peer IP, is what I mentioned just now. And R3, the only thing I know about R1 is the peer IP. And then we enable the encryption, and then we set the VPN map, and then we can configure the VPN, and the VPN can run. You can see, you can show that most of the, if you show crypto IPsec SA, you will see that all the packet, right, exiting here, which is the message, exiting here will be in encrypted format, and entering here will be in encrypted format, and then decrypt back to the message to PC3, right, or PCC, right? Okay, so this is the step. The step, as I mentioned, is exactly the same step as what I summarized here. It's important to know the peer. For this, we know the peer is this. For this router, we know the peer is this. And then we have the same encryption and decryption key for this router and this router. This is the simple setup for VPN, right? So if you do VPN site, VPN site to site, VPN site to host, and VPN host to host, the concept is the same. You need to know the public IP, and you need to know the encryption technique that you use. The public IP means your peer IP and your peer IP. Okay. So now let's go back to the configuration step by step. So this is the concept, right? This is the concept which I already explained in summary, right? You have the introduction here, which the network topology shows 3 routers. Your task is to configure router 1 to router 3 to support site-to-site IPsec VPN, right? The IPsec VPN tunnel is from router 1 to router 3 through the router 2. Router 2 acts as a pass-through and has no knowledge of the VPN. So IPsec provides secure transmission of sensitive information over unprotected public network, such as the internet. IPsec acts as a network layer, protecting and authenticating IP packets between participating IPsec device. It can be peer or such as a Cisco router, right? So this is the key they share, which is the step 3. And then this is the policy of parameters. The peer address is very important, right? The peer host name and the transform set that you set here, VPN set, the transform set that you set here. Okay. So then we configure, right? We configure one by one. And at first, when we have this network here, we should ping the whole network to confirm the connectivity, right? It should be successful, right? So we can confirm here the connectivity, right? We should confirm the connectivity, right? It should be all successful, right? You see, it should be all successful, okay? So this is a fully connected, right, network, okay? And then identify the ACL, right? For example, you want to place the ACL. You want to place the ACL to only identify the traffic from LAN on R1 to the LAN on R3, right? This interesting traffic will trigger the IPsec VPN to be implemented wherever there's a traffic between R1 and R3. All other traffic source from LAN will not be encrypted. Remember, this is due to this implicit deny all, right? There's no need to configure a deny any statement, right? So if you configure this in R1, which means that, and you configure also this in your R3, which means that this network only permit this and this to communicate solely. Remember, you only permit this traffic to allow inside here. Okay. So you're using this as a base. So the first one is to configure your R1 access list, right? And you see the access list is 110. Afterwards, we will apply this 110 to your IPsec so that you can have a secure transmission like this. Other party, you don't care. You have a secure IPsec VPN tunnel which connects this PC to this PC only using this IPsec tunnel. All these other you come in, it will be blocked. Other to come in, let's say from this network or from this network, it will be blocked. Okay. So the first one is R1. You are going to permit So this is enable, this is user mode, then we go to enable mode or privilege mode, then we go to config T, right? So we have access list 110 permit IP 192.168.1.0 0.0.0.255 192.168.3.0 0.0.0.255. So what you're permitting is you're permitting IP from 1.0 to 3.0. Okay, so right, same, right? For R3, you will also do the same thing. Enable config T. You will also do access list. See what number they want to do. 110 also. Yeah, also 110. Also 110, right? And you want to permit IP from 192.168.3.0 0.0.0.255 to 192.168.1.0 0.0.0.255. In this side, you want to permit only IP from 3.0 to 1.0. So that's why it is 3.0 to 1.0. Okay. From this side is 1.0 to 3.0. From this side is 3.0 to 1.0. So now you finish the initial ACL step. Not the first step yet. Okay. So then you go to the next. You want to configure the neighbor. Remember the neighbor. So if you take a look, right, you want to configure the ISA KMP phase 1 properties on, sorry, it's here. You want to configure the ISA KMP phase 1 properties on R1, right? So the R1 will look at the neighbor. This is the neighbor. This is the key, right? And this is your group, the group 2. Okay, so this is the policy of encryption, and the is a pre-shared key. That means this one is the same key. The VPN PA55 will exist in R1, will exist in R3. The key is the same because it's a pre-shared key, and the encryption is AES. The crypto policy is 10, and you have, this is the peer address. Remember, I told you before in here, this peer address is very important. This peer address here is very important. This peer address here is very important. This peer address here is very important. For R1, you need to know the 10.2.2.2. For R3, you need to know the 10.1.1.2. Okay, right? For this one, 10.2.2.2 and 10.1.1.2. For this one, you need this one. For this one, you need this one. Okay. So now you configure the second thing. It's in R1, so you need the R3 IP. And R3, you need the R1 IP. So you configure the second step. So if you take a look at R1, now you want to configure your policy. Crypto ISA KMP policy 10, right? Encryption AES, authentication, pre-share, group 2, exit, crypto ISA KMP key VPN PA55 address 10.2.2.2. Your neighbor IP. This is your neighbor IP. This is your key, which is a pre-shared key, right? So you have finished the most important part, right? And if you realize the R3 is the same, right? This is the R1, and the rest is the same, right? So you can configure your R3, right? So you have the crypto ISA KMP policy 10, encryption AES, authentication, pre-share, group 2, crypto ISA KMP VP NPA 50 address 10.1.1.2, right? Is the other side IP, the neighbor, your peer, important. So that you finish the second process, right? And then you configure the third process. Remember, this second process, then the third process. The third process is to configure, right, the setting up exactly of the peer 10 and applying the ACL within this connection. This is just to bind everything, right? To bind everything. To bind what you have coded, what you have given the command to bind this and to bind this and this together, to access this 110 and also this configuration, to bind it together. You see, all this is nothing new. You just say the peer is this, the transform set is this name. You can make a different transform set name, but both names should be the same. This is a name. Any name can be used. But if you use a VPN set, the other one you must use VPN set also, right? So this is the binding part, the second part of the properties. After that, you place it in the interface, and the interface has already completed. That means the VPN IPsec is completed. You place it in the interface, the VPN map here. Okay, so this is the final step. Remember the final step, to bind every configuration that you make in the previous two steps. And then the binded configuration or the binded information, you place it in the interface, the outgoing interface, and your IPsec is ready. That means, which means that now this and this can talk securely. Can talk securely. 3 steps. So let's do R1, the third step. R1, the third step. The third step says that you need to bind, right? You need to bind the So the third step says you need to bind, right? You need to bind these two together. Bind whatever access list that you have mentioned and also the ISA KMP policy. So the first is to make sure your crypto IPsec transform set. This is a name. This is a name. You cannot change this name. So you can use a VPN setting. VPN setting. You can use a VPN setting. And the encryption technique. And also the encryption and also the hashing. And also the hashing use. Encryption technique and also the hashing use. Okay. Then you do the mapping. Crypto map, VPN map. This mapping will be placed in the interface, right? 10. Remember the policy is 10. Policy number 10 here. So now we say VPN map maps to the policy 10, which I described here. IPsec, ISA KMP, right? Okay, so why? Because this VPN map has to map 2 sides. So it's trying to tell you will be disabled until a peer and a valid access have been configured. Unless the other side, R3 is configured, the VPN map will not be in action. Okay, so now the VPN map, the description is, this is just a description. You can put anything, VPN connection to R3. It's just a description. You can do anything. So, and then you set peer 10.2 10.2.2.2. This is a must. Remember here, you already say the peer is 10.2.2. You cannot have anything other thing, any other thing except 2.2. And then you set the transform set to VPN set. Remember here, you already say transform set VPN set. Don't put other names. Then match the address, the ACL, right? 1110. And then you are finished. The third step.
To genuinely emphasize.
Right? So you finish the third step in R1, and now you want to do the third step in R3. Right? Same here. You see? The only thing that different is the peer. Other things is the same. Because the VPN map should map to the same map as R1, the VPN set should map to the same set, the same VPN setup in the R1, right? So now if we go to R3, we can complete the PSEC from set VPN setting. The name should be the same because it's a VPN, it's a two-site. Cannot be one site different. Right? The first one, and then crypto map VPN, the map map to policy 10 IPsec ISAKMP, right? And then description VPN connection to R1. Set here 10.1.1.2, right? And set transform set VPN setup.
Okay, well, what time are you coming home?
And
definitely
address
before
110, match the ACL, and then you are complete. Your VPN setup is complete. Now you have to place this crypto VPN map in the interface, right? Which means you place the VPN setup using the VPN map in the interface, right? So the third part is already finished. Now what you do is place the VPN map in the interface. So if you go back to R1, right, you place it in the interface. Interface S010. Okay. S010. Right? And then you put crypto map VPN map. Right? So you place the map in the interface. Okay? So once you place the map in the interface, you can see this ISA KMP is on, it's switched on, because you have the peer, right? And same, you go to R3, you go to interface, what interface is it? S010, okay, same S010, right? Interface S010, crypto map VPN map, right? Oh, sorry, too many slash. Crypto map VPN map. Okay, so you place. Now both is on, right? Now both is on. Now how do I check if the crypto map is switched on or not? if the crypto map is switched on or not. Now it says in here, initial when I designed this, I already said only when traffic, the yellow color network to the yellow color, it will be in the VPN, which means that between this and this, I will only use the VPN. If my PC here, access PCB, it will not be in the VPN, right? So now I access PCB, for example, the PCA ping BCB. PCB is what IP first, 2.3. So I ping, right? I ping 192.168.2.3. Right? No problem. Right? I ping. And did I use any IPsec? Did I encrypt any packet? I can check, right? By typing a command, show crypto IPsec SA, right? Show crypto IPsec SA. So if you go to R1, right? Remember the show command is always in the privilege. Show IPsec, show crypto. Crypto IPsec SA, right? Show crypto IPsec SA. You will see that, oh, there is 0 packet encrypted. Because just now, what I did is I ping PCA to PCB. Now then I ping PCA to PCC. If I ping PCA to PCC, what is PCC? IP 3.3. So I go and ping 192.168.3.3, right? You will see it will take more time, right? Because it is trying to encrypt the packet. So same thing, if I show IPsec, crypto IPsec SA, you will see that the packets that is encapsulated or encrypt and the packets that is decrypt is increased. Same here, if you show exceed to the privilege mode and then show crypto IPsec SA, right? You see, this has 3 packets only. Same thing, if PCC ping PCB, right? Command prompt, I ping 192.168.2.3, which is PCB, right? I ping. If I ping PCB, if I go to my IPsec, right, I will see that it didn't increase any encrypted packet. Let's say I ping 1.3, right? I ping 1.3. Now I have 4 packets. You will see that it will increase to 7 because I have encrypted 4 packets. Okay, so this is the meaning. When it is secure, you access this to this, you will ensure that packets outgoing will be in encrypted format. The message in encrypted format, the blue color line, and then it is decrypted back. Clear? But otherwise, if it's going to PCB, I don't care. It is not in encrypted because this, I do not need to use my VPN. I do not need to use my host site-to-site VPN. Okay, I hope this is clear for the task 5. Task 5. Is it okay, task 5? Okay, student. Lim Kangji or Huam Zekai. Okay, task 5. Ku Hing Chun. Did you attempt the task 5? Chia Pei Yong. Did you attempt the task 5? Okay. So is the explanation clear? Ku Hing Chun? Huam Zekai, is it okay? So now you can actually try out, right? If Ku Hing Chun, is the explanation okay? How you want to do it? The 3-step. Remember the 3-step. So if the pink color go to the pink color here, you don't care. It's not in encrypted. If the green color go to green color, you have to be encrypted. It's going through it's as though you have a direct route to from the R1 to the R3. Okay. So now this is today's lab, right? We configure the VPN, right? Network to network, and in your free time, you can actually try out the Lab 5 homework packet. In this Lab 5, you can see, right? In this homework, let me describe to you. In this Lab 5, right? R2 and R4 should be configured in such a way that PCB-B should use VPN to access web server. To access web server. Web server is here. PCB-B, which means, right, you have this network here. Okay, this is 5. Now you want to set up the VPN, right? In the homework. In the homework, you want to set up the VPN, which means this to this VPN. You want to set up the VPN. Right? You want to set up a VPN like this. Now you can see that the VPN is set up. Remember the 3 things. The 3 things is the first thing that you need to do. The first thing. Remember the first thing you need to do? The outgoing. Remember just now, Dr. Lau said, the first thing, the second thing, and the third thing. The third thing, of course, it involves this router, it involves this router. Don't do anything in R1 and R3, right? Now the first and second thing, either you choose this route or you choose this route. If you choose this route, your first and second will become this interface and this interface, remember. If you choose this route, this green route, your interface will become this interface and this interface. If you choose the blue color route, it will become this interface and this interface. So the peer will be different. The peer will be different. Please understand, when you configure the VPN, there are many ways to reach the router. Why we give you this homework is because there is many ways to reach the router. You can have this router through this router interface or through this router interface, right? So you can use the green color to set up your peer for the 3-step, or the blue color to set up the peer for the for the blue color set. Right? So I hope the 3-step is clear. If you look at the 3-step, right? The first step is to set up the ACL. Second step is to place all the parameters. Third step is to bind all the parameters. And it's important the peer, right? The peer and the ACL and the policy number, right? So if you take a look at this homework here, you look at your config, right? Your S010. This is your 1.1.1.1. This is your 1.1.1.1, which means this side is your 10.1.1.1. Okay, .1. We put green. And your S, and if you take through here, this is S011. Your S011. Your S011 is 10.2.2.1. So this is 10.2.2.1. Okay. For this side, right, R4, your S010 is 10.4.4.1. 10.4.4.1. 10.4.4.1. And the S110, 10.3.3.1. S011, 10.3.3.1. This one is the blue color one. So you must remember. Why I click blue color already? Okay, my mouse something wrong. Right? So you know what you cannot do is, because the network is like this, you cannot set this IP with this IP. You cannot set the peer like this. You cannot set the peer like this. You cannot. You cannot set the peer like this. You cannot. The peer only can set among the green color or among the blue color. Right? Please note this. Okay? So please set only among the blue color for the homework. Right? For the homework. So this is your 1 and 2 and then the 3. You can use back the same setting, no problem. You can use back the VPN set, but only change the IP. You can use back the 110, no problem, right? You can use back the policy 10, no problem, but just the IP, please make sure. Follow the concept of what Dr. Lau teach. Only the peer which have connection. Because why you cannot set 10.3.3.1? Because in your perspective, how to jump over to the other side. So that's why the VPN will not work, because there is no network to jump to the other side. Understand? So 10.1.1.1, the peer is 10.4.4.1. 10.4.4.1, the peer is 10.1.1.1. This is the peer. Okay? Other things, you can use back the same VPN map, VPN setup, no problem. If you set up like this, you can run also, which means that if my packet, right, if the packet from B to web server, this will be using the VPN. Okay? Otherwise, if I access, for example, B to A, it is through normal, normal, not through VPN. Okay, so that would be all for your that would be all for your today's lab. Is it clear? Is it clear, student? Okay. For the even the homework, right? You can use what I've discussed, and also the mitigating ICMP abuse, right? Now, if we want to mitigate ICMP abuse, we can prohibit echo reply and unreachable. If we can prohibit in the access list and place this access list in the router interface, we actually prohibit the attack called ping of death, right? The attack called ping of death, or the attack called ICMP ping flood. Remember this one. ICMP abuser, there's many. ICMP abuse, there's many, right? For example, ICMP abuse can be right, ping of death, or ICMP ping flood. So in order to prevent these two service disruption, right? If you ping of death, you disrupt the services of the router. So, and also the ping flood, right? You disrupt the service of the network. In order to prevent this, you can actually prohibit using the ACL to prohibit any echo reply and any unreachable comment from the ICMP. This is an extended IP. This is very important. Once you get hold of your router, please make sure this one you configure first. This is not a very trivial method. This is a very important method. Okay, ping of death will make sure your router doesn't service any other people except people pinging. Every time have to service the ping. Then the router does not service other packet. So in order to mitigate ICMP abuse, please understand, please do this right, please do this to mitigate, to copy this in the in the ACL, right? So that would be all for today, right? I hope everything is clear. I completed all the lab 5. If you have any problem in lab 5, please let me know, right? So any other thing you want to raise? Any question? Student, any question? All right, if no question, then I will post the attendance.